Welcome everyone. Today we're looking at standard form part 1, which is just an introduction to standard form itself. So we're going to be looking at covering what actually is standard form and how do we convert between what we call ordinary numbers, which is the normal numbers you're used to seeing, and standard form itself. So beginning with what is standard form. So standard form is basically a useful way of expressing very large or very small numbers. We put numbers in standard form by writing them in the form a times 10 to the b, and a and b are just general letters here to represent particular numbers, where a is between 1 and 10 and b is an integer, which is a bit strange. You probably haven't seen anything like this before unless you've obviously done standard form before. Okay, but basically what this form is going to do for us is it's going to allow us to turn very large, or as I say very small numbers, into a more useful expression, to a more useful form. So looking at 260,000, so 260,000 here, we're going to put this into standard form. Now the first thing you'll notice about our number a at the front, we said here that a has to be between 1 and 10. So looking at the numbers you've got there, the only way we're going to get a number between 1 out of 10 is by putting our decimal in between the 2 and the 6 here to get 2.6. If that decimal was anywhere else, then you wouldn't get a number between 1 and 10. So we know that this number here has got to be 2.6. And the bit after it's times 10 to the power of something. Now if you think about it, 260,000, the number we have on the left here, would be 2.6, okay, if that decimal was there, 2.6, times 10 would move the decimal 1 to the right. And so if we carried on doing this twice, 3 times, 4 times, and then 5 times, so we times by 10, 3, 4, 5 times, we would have our number. So in other words, 260,000 is just 2.6 times 10, 5 times over. Now that's obviously not a very handy form because we still have to write 10 5 times out. So what we can do instead is get rid of the other 10s here and write it as times 10 to the power of the number of 10s we had, which was 5. So 2.6 times 10 to the power of 5, and this would be standard form here. This is basically what it does. It condenses down very large and in a minute very small numbers. So next up we have 0.00035, and we're going to try and write that in standard form again. Now the only place we could put our decimal, we'll do this in red, would be here, 3.5. So we know that our number has got to be 3.5. That's the only place we could put it to get a number between 1 and 10. Times 10 to the power of, now this one's a bit of an awkward one because we're timesing it by 10 to the power of something, but somehow we've got to try and make it smaller, because you can see we've got 0.00035. So we can only actually divide by 10 to get there, surely, right? But if you've watched our video on indices, okay, we figured out that 10 to the power of a negative, so 10 to the power of minus 1, is actually just 1 over 10. So what this actually means is, if you times something by 10 to the power of minus 1, you're essentially timesing by 1 over 10, which is the same as, dividing by 10. Dividing by 10. And so we'll leave that as a side note down the bottom there. So in other words, if we want to work our way from 3.5 to 0.00035, or the decimal, remember we're putting here in between the 3 and the 5, we would have to divide by 10 1, 2, 3, 4 times to get the decimal place over there. So do times 10 to the power of minus 4. Because remember, a negative power actually divides by 10 rather than times it by 10. And we have to do that 4 times, hence the power of 4. So 0.00035 would be 3.5 times 10 to the power of minus 4. So converting standard form. So basically we're going to be doing what we've just done there on a few different examples. So this one here, I'm not even going to read out the size of that number. You can see that's quite a big number there. So to put this in standard form, we need to choose our number, which would be 2.56 at the beginning. That's the only place that we could put our decimal in order to get it between 1 and 10. So our decimal is there. And the amount of times we're going to have to jump across to the right, so times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8. There's 8 steps, 8 jumps if you like, to get the decimal all the way over to the end. So 2.56 times 10 to the power of 8, so times 10, 8 times over, would give you this number on the left here. Next up, again, we're going to put our decimal here. So you have 7.086, and we should remove these after we finish. So we get 7.086 times 10 to the power of, and how many jumps we're going to have to go? 1, 2, 3, 4, 5, 6. To the power of 6. 0.00004. Well, this is equal to, removing the last one. So it's not necessary to remove it. I just want to keep that clean on the left hand side so you can see that that number on the left is definitely equal to that number on the right. So 0.0004. What we're going to have to do here is put our decimal at the end. That'd be 4 times 10 to the power of, and because we're making this smaller, we're essentially dividing by 10. We know it's going to be a negative power this time because the decimal's got to go the other way. Of 1, 2, 3, 4, 5 steps to get back to there. So be to the minus 5. And lastly, here, and I'll leave the decimals in for these ones just so you can see an example of the step-by-step process we're doing. This one here, we'll put the decimal in here to get our number between 1 and 10. So you get 3.02 times 10 to the power of, it's going to be 1, 2, 3, 4, 5, 6, 7. So be minus 7 there. And that's how we convert ordinary numbers on the left into standard form on the right hand side. And we're going to go the other way now. We're going to convert some standard form into ordinary form, so into ordinary numbers. So 8.9 times 10 to the power of 5. So 8.9. And we're timesing it by 10 5 times over. So 10 to the power of 5. That's going to jump this decimal place 1, 2, 3, 4, 5 steps to the right. And all these are going to be filled in with zeros here. So we get this number here, 890,000. Similarly, 4 times 10 to the power of 7, put our 4 in, and we're timesing it by 10 7 times, so it's going to jump that decimal 1, 2, 3, 4, 5, 6, 7. You get 1, 2, 3, 4, 5, 6, 7 zeros on the end of there. 6.1 times 10 to the minus 3, so this way the decimal is going to go in the other direction since the power is negative. So put our 6.1 in, just for the time being. And we're going to have to go 3 places to the left. So 1, 2, 3, that's where our decimal belongs. So we can get rid of all of this and fill it in with zeros. So we get 0.0061. And lastly, 9 times 10 to the negative 4, let's put our 9 in. And again, the negative power means the decimal, which is previously here, is going to move 1, 2, 3, 4 to the left. So that's where our new decimal lies. And fill all of this in with zeros. And that'll be your answer. That's how you convert between ordinary numbers and standard form. And we're all done there. So that is the introduction to standard form. We've managed to look at what standard form actually is, as well as converting between ordinary numbers and standard form. Thanks a lot for watching. Thanks again for watching. For more great resources to help build your confidence and ace your exams, feel free to head over to www.katala.co.uk, where you can sign up for free today. If you enjoyed the video, please like and subscribe, and if you have any questions or suggestions, just comment down below. Thank you.